So last time we already calculated our initial value p0 of 400. The rate is 0.15, so we have 1.15 for the growth factor. So the expression becomes 400 times 1.15 to the power of t. So now let's look at the answer choices. Which one matches? It looks like C is our winner. So here's why the other options are wrong. A, 400 plus 0.15t. This is linear growth. This would mean adding a fixed amount of 0.15 plants per year, which doesn't really make sense as a percentage. Exponential growth isn't about adding, it's about multiplying by a factor that gets repeatedly applied. B, 400 times 0.15 to the power of t. This would mean the population is decreasing and shrinking by 85% each year, as 0.15 is less than 1. The growth factor was miscalculated. D, 400 times 1.15t. This looks like multiplication, but is also a form of linear growth. You're just multiplying by t, not raising to the power of t. The exponent is what makes it exponential. And lastly, E, 400 plus 1.15 to the power of t. This just doesn't make sense. You don't add the initial amount to the growth factor raised to a power. Key habit for exponential growth is to remember, percentages over time mean multiplication by a factor raised to a power. Don't get fooled by linear lookalikes. Follow for more SAT math strategies, and if you haven't, subscribe to my YouTube for deeper dive videos.